Okay, so we are going to continue on with exploring TVM Solver, and what we're going to do is we're going to look at an investment scenario. And while we're not really going to learn anything new, I would really like you to be attentive to this, because this is hopefully a life lesson that will mean something to you. So what we're going to do is we are going to explore the investment strategy of two different people. So two people are going to invest, and we're going to look at how they end up in the long run. And this is going to be an investment scenario with retirement squarely in mind. And these are going to be real world numbers. These are going to be the real deal. We're going to explore, and I'm hopefully going to try and teach you a life lesson here, other than, be nice to people in general, although I'm not a great model for that, so I apologize. So here we go. So what we're going to do is we're going to have Jake and Jesse, J and J, are saving for their retirement. They're going to have two separate strategies. So here is Jesse's strategy. Jesse starts investing for her retirement at age 20. So Jesse is going to put money away from the time she's 20. And here's what she's going to do. Every month, Jesse is going to invest $250. Okay? She does this until her 40th birthday. Then leaves that money and doesn't touch it until her retirement at age 65. So if we think about it, so this is what it would look like for Jessie. So she's going to start at age 20, and here's 65 out here. So here's age 20, here's age 65. That's not a 6, 65. And here is age 40. And Jesse's going to put away 250, and then 250, and then 250, and then and then right here she's going to stop. She's not going to make any more investments, but she's got a pool of money from these $250 that she's invested all of that time. But she doesn't do anything else with it. She just lets it sit. So it just sits in the account and it grows into some bigger amount. It's going to grow, right? It's going to get bigger. So she invests for a total of 20 years, right? So that's what she did. She started early, put away $250 per month until she turns 40. She's got a pool of money there now. She's like, I've had enough of this investment stuff. She stops investing and then leaves it and lets it grow until she's 65. Okay, that's Jesse's strategy. Along comes our good friend Jake. Let's make Jake this color. So Jake, that's not how you spell doesn't. Oh my goodness. doesn't start investing until he is 40. So Jake parties away, goes works at the Giant Tiger, gets himself a banging car, puts a great big stereo with a subwoofer in the back. He's the coolest kid in, his, 10-foot radius. But he doesn't start investing until he's 40. And then at age 40, he's like, you know what? I better do something. So he then begins. He now invests because he's got a good job. He invests $300 per month from age 40 until age 65. Okay. So his timeline looks a little bit different. So age 20 gets himself a nice set of wheels. Got a big subwoofer that thunders. Coolest kid in school. Okay. Doesn't invest. Nothing. So at this juncture, he's got zero. But then he's like, all right, time to start. So he invests 300 and then 300 and then 300. And he keeps on investing 300 until he hits the age of 65. And he's got a pool of money. Jesse's got a pool of money. What we're going to do is we are going to compare these two strategies. Now, they're going to invest and get the same interest rate and its same investment strategy overall. Jesse just does it early, Jake does it late. So they each earn 8.5% per annum compounded, and it's going to have to be monthly because we're going to use that same tool again. Okay, compounded monthly. Now, my question, and I genuinely want to think about this a little bit. Two things we want to answer right away. First question I want you to answer is how much money does, oh wow, I'm like broken on my spelling of does. Does Jesse invest total? And then the exact same question, does Jake invest total? Okay, so we're going to work through these ones together because, it's not all that complicated. We don't need the TVM solver. We can use regular solving. So Jesse's putting away $250 a month for 20 years, right? So for Jesse, Jesse takes $250 per month, so 12 months for 20 years. So I'm going to grab a calculator. And we're going to find out how many of Jesse's dollars she puts in the bank. So 250 times 12 times 20. So in total, Jessie invests 60,000 of her own dollars. Now clearly there's going to be more money in there because she's going to earn interest. That's how much Jessie earns, or how much Jessie invests. Let's look at how much Jake invests. So Jake puts away 300 per month, and he does it for 25 years. So clearly, Jake is going to take more of his own dollars and put them in the bank. So 300 times 12 times 25. So Jake, he invests a fair amount more. Jake invests $90,000. So Jake invests 50% more money than Jesse does. There's Jake. So Jake is feeling all sorts of smug now. He's got a goofy, smug smile. He's like, I've got more money than Jesse does. But does he? Let's figure this out. So we know that Jake invested an extra 30 grand. But the proof is in the pudding. We want to know how much money do they end up with. So question 3 is going to be, how much is Jesse's retirement fund worth at age 65? Okay, so we're gonna have to do a few things here. Jesse's a bit more complicated, right? So we had that timeline up there. So Jessie takes and she puts away $250 per month for 20 years. So we're gonna have to do this in two pieces. We're gonna have to find out what it's worth when she's 40. That's when she stops investing. Okay, so let's figure out at age 40 first. So age 40, we're going to figure, and then we're going to have to do something different. So I'm going to go off that TVM solver again. That's not it. Let's go back to the TVM solver. Here it is here. We're going to reset it. So present value, well, she starts with 0. Her payments, we said, are $250 per month. Future value is what we want to figure out. The annual interest percentage, I don't remember what I said, 8.5%? 8.5%. So we're going to come back here. Annual interest rate percentage is 8.5%. Number of periods. Well, she does it for 12 months a year, so 12 per year for 20 years, so for 240. And she does that monthly. And then we're going to figure out what the future value is. So by the time Jessie hits her 40th birthday, it is $156,749. So let's go back here. So 156,749. 156,749. So 156,749, and then I think it was 70. Let's just check. 74. 74. Let me erase that. Okay, 74. So this is how much money she has on her 40th birthday. And she stops making payments. So this is a lump sum now, right? So she's going to take this lump sum and she's going to just let it percolate, not going to add any more money to it, but she's going to let it grow, and she's going to let it grow for 25 years. So that means that now from age 40 to age 65, she can use the formula that is FV equals PV bracket 1 plus I to the exponent n. Okay, so that's good. So FV, PV, I, and n. Future value, that's what we want. Present value, this is the start of that 25-year period. So 156,749.74. And the interest rate is 8.5. But then we have to divide it by 12 because it's monthly, and then divide it by 100 because, well, it's got to be a decimal. So I'm going to grab a calculator. I can't do that in my head. It's not going to be a very nice number, and I apologize for that, but it is what it is. So 8.5 divided by 12 divided by 100. So 0.00708. I'm going to do that. So 0.00708, and then I think it was 3 repeated. Yeah, 3. And you're like, what difference? It actually makes a difference, okay? And then n, she does that. So the investment's going to sit from when she's 40 to 65. So that's 25 years, but I have to multiply by the 12, so times 12, which is 300. Okay, so substitute these things in. Future value is equal to present value. Well, it's 156,749.74 bracket 1.0070833 to the exponent 300. So let's dump that into our calculator. Okay, so these are real numbers. That interest rate's fairly high, but honestly, over a 20-30 year period, that's not unrealistic in the least. Okay, so 156,749.74 bracket 1 plus, and I'm going to keep all of those decimal places so I can use the last answer there, to the exponent 300. So at the end, these are real numbers, folks. 1.3 million. 1,302,655. 1,302,655.08. So those are real. Like, honestly, those numbers seem staggering, I know, but that's actually real. If at age 25 or 20, excuse me, Jesse put away $250 a month for 20 years and then stopped and then just let it sit until 65, she would have $1.3 million. Real numbers. That's on the assumption that we could get 8.5% interest. Now, let's look at Jake's. The smug smile Jake. Jake puts away $300 a month for 25 years. That's all he does, right? He just is like, starts late, but he's like, I've started late, but I'm going to go longer and I'm going to put more away, right? So Jake puts 50% more away, but he starts later. So let's go and look. So let's go over to this again. I'm going to reset this. So the present value, Jake also starts with zero. Right? There it is, zero. Payments. His payments are bigger. His payments are going to be $300. Value, what we're going to solve for. Annual rate, 8.5%. Periods. Well, he's going to do it for 25 years times 12. So that's 300. And then monthly. Future value. $309,617.49. Okay? 309,617. What a difference. So Jake's, so this is IV, I guess. How much is Jake's retirement fund? $309,000. What was it? $309,617.49. $617.49. So Jessie, in spite of the fact that she invested like only 2/3 of the amount that Jake invested, ends up with $1 million more because she started early. That is not fake. That is not cooked. That is not anything. That is the truth of the matter. Okay? My lesson to you today, children, is that it makes an immense amount of difference to your later in life lifestyle, let's say, when you start investing. And even if you start investing small, Jesse could have invested $150 a month and still been substantially further ahead by doing it early, putting away $50 a month. Honestly, $50 a month for that early period probably would have come pretty darn close to what Jake has here. Okay. I just want to reinforce to you that investing early and consistently is the key to financial success. Okay. By far, it is putting it away early, because the longer you get the money there, it compounds. And so your money earns interest early, and then your interest earns interest, and then the interest on your interest earns interest. And the time value of money is enormous. Okay. So now, like I said, that interest rate, and if you're going to go and trot this out, some people will be like, oh, that's not a very realistic interest rate. Over any 20, 30-year period, that's actually a very reasonable interest rate. Right now, interest rates are the lowest they have ever been in history. Legit, the interest rates have never been lower than they are right now in history. History tells us they're probably going to go back up. And not only that, if you're investing in things that are not just a bank account, interest rates are pretty good. So I hope that you walk away with this with some wisdom that investing early and consistently makes a big difference. Now, a lot of my friends fell into the trap, and I will admit to an extent I did as well, that you start investing early, you start investing when you're 20, 22, 23, you put money away, and then you're like 27, 28, and you have to go buy a car, and you're like, I've got this money sitting in the account. Maybe I'll just pull that out. Please don't fall trap or victim to that. Let it sit there. If you're absolutely desperate, you can, but do everything you can to get the money back into the account. Okay, so very realistic examples. Hopefully, it's enlightening. Next week, we are going to talk about the different investment vehicles that you have, how you can put money like this away and let it grow, investment strategies, and we're going to start talking about some real world finance. But hopefully, this has opened your eyes. I'm not going to give you any homework on this. I would encourage you to play with that TVM solver and look at different scenarios and look at mortgage payments and all of those things. It's eye opening to see these things because a lot of the time I don't think anybody would have envisioned that, for instance, Jesse having invested only 60,000 to Jake's 90,000, that Jesse would end up with $1 million extra, right? This stuff is not intuitive. So the more you play with those things and the better you get an understanding, hopefully it's more persuasive for you and you can learn to do the right thing. Anywho, have a lovely remainder of the week.